Hello once again, everyone. This is Mr. Ballard. I wanted to talk to you today a little bit about functions. Now, this is our first video for pre-calculus, and I think it's going to be a pretty good one. Usually with this year, we start off with a gigantic Algebra 2 review, and everyone hates it. It's really long, really complex. We cover just about the whole year of Algebra 2 in about a week. So we're not going to do that this year. We're just going to jump straight into the pre-cal, go into functions. A little bit of it's going to be review, but not the majority of it. So here's how this is going to work. I have some notes that are typed up with me here. I've given some prompts as well as somewhere to go with this. Now, what I would do if I were you is go ahead and copy down the notes with me. You can pause the video at any time you feel the need to, and you can continue writing on. So let's go ahead and start by writing the definition of a relation here. Now, a relation is a rule of correspondence between two sets of quantities. It's like a relationship. You take two quantities, and the relation between them is what we refer to as a relation. It's kind of like the temperature outside is related to how many ice cream cones are sold in a day. In other words, if it's really cold outside, then you won't sell very many snow cones or ice cream cones. But if it's a pretty warm day outside, it's a fair chance to say that you will. So a relation is a correspondence between a set of data. So a relation can take many different forms. It can take the form of a graph or a set of ordered pairs. Make sure that you are writing this down here. A set of ordered pairs. It can be an equation or a verbal description. Right? Or a verbal description. Now, a function is a very special type of relation. A function is a relation which assigns each x value to exactly one y value. So in other words, there is only one y value for every x value. Exactly one y value. One y is going to be the key here, one y. Alright, now a lot of this is going to be reviewed, so we're just going to kind of power through these first couple of lessons here. No x value can be used twice with different y values. The graph will pass the vertical line test. In other words, if you pass a vertical line through it, it only touches your graph once. X is known as the independent variable. Also known as the output. Y is the dependent variable. Right? Now I know a lot of this is going to be second nature to you, so this is just giving me a format to kind of relay my thoughts. So domain, we obviously know that those are all of the possible x values, right? If you just remember, domain is all possible x values. The domain can be determined by the graph or by the equation, either one you want to look at. Range, on the same hand, is all of your possible y values. It just kind of makes sense that those follow each other, right? For a given relation. All right, so there's a couple of ways you can write your domain and ranges. There's the inequality version, which is what you see on the left here. These are called inequalities. And then there's the interval notation. Now the interval notation looks something like this. If your inequality starts at 3 and goes to 5 and x is in between that, then you'd say your interval is 3 to 5. Now the other thing we have to look at is, does it actually touch 3? So x is greater than or equal to 3, so it actually does touch. It can be equal to 3. So we're going to put a bracket around 3. It touches 5. X is less than or equal to 5, so we're going to put a bracket around 5. So a couple of things to remember here. Brackets are going to be the less than or equal to or greater than or equal to, and then parentheses are going to be what we call strictly less than and strictly greater than. No equal to signs. like in the second one here, from 3 to 5. This time, it does not include 3 and 5. Alright, so here, x is greater than or equal to 5. That means the smallest number in here is going to be what? 5. If x is going to be bigger than that, then the smallest number has to be 5. So if the smallest number is 5 and it does touch it, what's the biggest number that we could put in here? What's the biggest possible number you could think of? Well, the biggest possible number is infinity. Now we can't actually touch infinity, so infinity is always open. It's always going to be parentheses. Parentheses are called open intervals. Brackets are called closed. Alright, so x is greater than 5, strictly greater than 5. You're talking about 5 to infinity, parentheses everywhere. 3 is less than x, less than or equal to 5, so you're going to be talking about here 3 to 5 does not touch 3, does touch 5. So a little bit of review there on interval notations, just a little bit of something to go along with. Alright, now from there we get into what we call function notation. Now function notation is where you replace y with f of x. You say that here y is a function, so we're talking about f being a function of x. So f is the name of the function, so if this was a g of x, it would be g, that'd be the name of it. F of x is the y value or the output for a given x. So we're going to state the domain and range of these graphs down here. State whether the relation is a function. Always read the graph from left to right as x increases. Very important here. So domain, you want to look at how far left to how far right. Well, if we look at this graph here, how far left does it go? We have an arrowhead on this graph. That means it's going to keep going this direction forever. So is there ever really a spot where it's not going to be going left? No. So you know your domain is going to go from negative infinity. What's the farthest right that it goes? So I'm looking at my x values here. Well, here's where the graph stops, right here at 7, and there's no arrow on here. It is a solid endpoint, so I know it goes to 7. Question is now, does it actually touch that? So you know you can't touch negative infinity, so we're going to put a parenthesis there. This is a solid point, so it does touch 7. Put a bracket there. Range, same thing. How far down to how far up does it go? Now a lot of people, when they see range, want to go to the lowest point on the picture. The lowest point on the picture, which should be down here. But us being astute mathematicians, we know that this guy is going to keep going down forever. Well, if this guy keeps going down forever, that doesn't mean that negative 4 is where it stops. No, it keeps going down forever. So please don't get caught up in the picture, get caught up in the graph. What's actually happening to the graph over here at the end? It's going to go forever, go down forever, even off the graph. What's the highest it goes? Now, highest is a different story. It definitely has a highest point right here. This does not go up forever. It stops right here at 4. And it does touch it because it's a solid dot here. Alright, so is it a function? Vertical line test. Vertical line test says if I put a vertical line at any point in here, can you ever draw a vertical line and hit that graph more than once? If not, then it passes the vertical line test. Is it a function? Yeah, absolutely. Alright, let's go down here. We have our graph. Just kind of follow along. If you'd like to pause the video and get a picture of these graphs, kind of sketch them out, I'd highly recommend doing that. All right, number 2 here, domain. Now we have to look at a couple of things for domain on this one. From the left, how far left does this go? Well, it goes to negative infinity is what this arrow tells me. So I know I'm going to go from negative infinity, not touching that, to what? Well, it goes to -4. Does it stop at 4? Well, it stops down here, but it continues up here. See, this one here is at -5, and it's -4, -3, -2, -1. And then there's a gap between -1 and 0. If you look at this graph, there is absolutely no graph between -1 and 0. What that means for our domain is I can find any x I want. All my x's defined, 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 defined up to here. Up to -1. And yes, it does touch -1. And then it jumps to 0. Since there's an empty hole right here, it does not actually touch 0. And then it goes to infinity. This is what we call interval notation. You are picking up the intervals that the graph is defined for. You're taking the intervals and plotting them out, or writing them out in order. All right. Range. Now the range, how far down does it go to how far up does it go? This guy goes down to -infinity. This arrow means it's going to keep going, keep going, keep going. This guy means it's going to keep going, keep going, keep going, all the way up to +infinity. Is there ever a spot in the middle here where this graph is not defined? Is there ever a spot in the middle between bottom and top where we have holes, gaps, canyons we have to cross? No. So we say that it would go from -infinity to +infinity, or there's a shortcut for that. Looks like an R with 2 backs. This guy right here is called all real numbers. That's a shortcut. All right, all real numbers, no gaps. Vertically anyway, there's no gaps. Now what about it? Is it a function? Is there any point where you can drop a vertical line and hit this graph more than once? Yes, there is. What about right here? You see that? Hits it twice. Is this thing a function? No. Hit it twice. That's really all there is to it. There's nothing much else to it. That's all there is. All right, so a little bit of vocabulary here for you again. Again, if you want to pause, if you want to rewind, if you want to go back and listen to it again, please feel free. Really make sure you get the understanding here. A few more characteristics. A one-to-one function is a function which assigns each y to exactly one x value. Please, please, please make sure you get that down. One-to-one means each y has one x. Remember, a function means each x has one y. One y means a function. One x means it's one-to-one. And how do you tell that? Same way you do with a function, but now we use a horizontal line test. So draw an example of something that's one-to-one. Well, a one-to-one function is going to have a horizontal line that is only going to touch once. So in other words, something like this, even though it's a function, vertical line test is okay. The horizontal line test means it is not one-to-one. So it is a function, it's not one-to-one. So this is a no-go. But here's something to look at. So you get something like this. Horizontal line touches only once everywhere. Only once, only once, only once. Good. That's as easy as it gets. One-to-one. All right? So if you look back here on these other graphs, these are not one-to-one because it does not pass the horizontal line test. It hits here and here and here, if you can imagine my pen being a horizontal line. Same thing down here. It hits here and here. And this whole section right here, this horizontal line, makes the whole thing irrelevant. So even if that was the only part of this graph, it's still not one-to-one. Alright? Alright, so let's move on here. I want to try and keep this a little bit short. I'm going to try and get this done before the 20-minute mark. X-intercepts. A lot of stuff here is going to go into this. X-intercepts, very simply, it's where the graph, let me erase that. It's the point where the graph, point on the graph where y equals 0. That's what I wanted to say. Point on the graph where y equals 0. Also known as a root or a 0. Right? We learned that in some of our vocabulary. The y-intercept is the point on the graph where x equals 0. You can think of the x-intercept. This is where it crosses the x-axis. Y-intercept is where it crosses the y-axis. All right? Increasing, a function is increasing on an interval if x increases and y increases. Kind of makes sense, right? X goes up, y goes up, it's increasing. It's decreasing if x increases and y decreases. They're doing two different things. X goes up, y goes down. And it's constant if x increases and y stays the same. So what you're looking at here is as x gets bigger, what happens to your graph? You always look at it from left to right. So as x gets bigger, what happens to your graph?